In this video, we are going to be talking about using LCM to find equivalent fractions so that we can solve problems. All right, let's start with our key vocabulary word, the word equivalent. So we have two fractions here. This top fraction is 2/4, because I have 2 shaded in, out of the 4 total, and we're going to set that equal to 1/2. The reason that I can say that these are equal is because they're the same. Let's do that a little bit better. They're the same size, right? The fraction strips are the same size, and they're both shaded equally. So if I laid these two fraction strips on top of each other, they look the same. All right, so now what we're going to do is we are going to find multiples. Okay, so the question says list the first 5 multiples of 7. Okay, so I have my first multiple, my second, my third, and so on, all the way to the 5th. Okay, the biggest misconception is that people are not putting the first one in. So our first multiple is 7 times 1. Our second multiple is 7 times 2. Our third multiple is 7 times 3. Hopefully you're seeing a pattern here that the fourth multiple is 7 times 4, and our fifth multiple is 7 times 5. So making sure you do all of them, but really specifically looking at this first one here. If you miss this first one, there's a chance you could miss finding the least common multiple. So now we're going to move on to finding LCM, which is least common multiple. So we start by looking at the smaller number, 6. I'm going to find the first 5 multiples of 6. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. And 6 times 5 is 30. Next, we are going to look at 15. So because 15 is bigger, it's going to become larger with less multiples, if that makes sense. So 15, we do 15 times 1. All right, is there anything in common yet? No, because 15 would be right about here and there's nothing there, okay? If I don't know 15 times 2, I'm going to go off to the side and I'm going to add these together. That way, I can see what the second multiple is. The second multiple is 30. Do they have anything in common? Yes, they both have 30, okay? And since this is our first common multiple, that is our smallest one as well. So the LCM of 6 and 15 is 30. All right, so now what we are going to do is we are going to find the sum of 1/5 plus 6/7. But first, before we can do that, we need common denominators. When you add or subtract fractions, you have to have a common denominator in order to do that. So in order to do that, what we are going to do is we are going to find the LCM of the denominators. And when I look here, I have to say, okay, which set of numbers are the denominators? Is it 1 and 6 or is it 5 and 7? Well, remember our denominators are our bottom numbers. So it's 1 or 5 and 7. So what we're going to do is we're going to find the LCM of 5 and 7. Okay. So I'm going to skip count by 5s, 5, 10, 15, 20, 25. And I'm going to do the same for 7, which we actually already did earlier in this video. So I can just do 7, 14, 21, 28, and 35. So do we have anything in common? So there's no 7 up here. 14 would be right about here. 21 would be right about here. And then 28 is already over here. Okay, so what I'm going to do is I'm going to add more. So the next one for 5 would be 30. And 30 would be right in the middle of here, so it's not there. The next one's 35. And boom, there we go, 35. So our LCM of 5 and 7 is 35. This is going to become our denominator. So now that we have a common multiple of the denominators, this can become our least common denominator. Okay, so I'm just going to go off to the side just so I don't forget, and I'm going to write 35. Now we are going to use a giant 1. You did this in your CC1 class to find equivalent fractions. So here we go. If we think back to our learning target was I can use LCM, which is right here, to find equivalent fractions in order to solve problems. Okay. And remember when you're doing giant 1, right, it kind of looks like this. These are the same. And we're able to do this because it equals 1, and anything times 1 is itself, so it won't change its value. And that's the important part to remember, that the numerator and denominator have to be the same in order for that value to stay the same. All right, so what I'm going to do is I'm going to say 1/5, and I'm going to set that equal to something over 35. I'm going to do the same for 6/7, not 1/7, 6/7, equals something over 35. Now we are going to do our giant 1. All right, and now we can say, okay, 5 times something gives me 35. Well, no, 5 times 7. And the numerator and denominator have to be the same, so it's 1 times 7 is 7. So we have 7/35 plus 5, or 7 times 5 is 35, and they have to be the same, so 6 times 5 is 30. So 30/35. And now that I have a common denominator, I can add straight across. So 7 plus 30 is 37. 35. All right, so this is kind of like our first answer, right? If this is as far as we can get at this point, that's okay. The next step would be to say, okay, this is an improper fraction. So I'm going to take 37 and I'm going to subtract 35. And you get 2. So 35 goes into 37 one time. You are left with 2 left over, and your denominator stays the same. So you could either have 37/35 or 1 and 2/35. All right, so our last problem here that we are going to do is finding the difference of 4 and 1/4 minus 1 and 4 and 1/4 minus 1 and 5/6. Okay, so we're not going to go step by step. We're just going to say, okay, let's look here, our denominators, and let's find an LCM. So I'm going to go out 5, 4, 8, 12, 16, 20, and then 6. I'm going to go 6. 6 is not in the top list, then 12, and there it is, 12 and 12. So I'm not even going to go any further. What I will do is I'll say, okay, 4 and 1/4 equals something over 12, and 1 and 5/6 equals something over 12. Okay, now we're going to use our giant 1s. 4 times 3 gives you 12. So I'm going to do the same thing for the top. And you can always go back to your LCM list and multiples and say 1, 2, 3. 1 times 3 is 3. And then 6 times 2 is going to give me 12. So I'm going to do 5 times 2, and that gives you 10. Now, this is kind of a lot of steps here. Okay, now I have 4 and I'm going to write it in pink. 4 and 3/12. And actually, I'm just going to rewrite it. 4 and 3/12 minus 1 and 10/12. But if you remember 3/12 minus 10/12, we cannot do that. So we are going to have to borrow. So I'm going to borrow 1 from the 4, and it's going to become 3. And then I'm going to add 12/12 to 3/12. So 12 plus 3 is 15, so this becomes 15/12. So 15/12 minus 10/12 is 5/12, and 3 minus 1 is 2. So there was a lot of steps there. Okay. All right, so remember, our learning target was I can use LCM to find equivalent fractions in order to solve problems. So remember, first you find the LCM of the denominators. And we're going to use a giant 1 to find those equivalent fractions, and then we can solve those problems. If you have any questions, please come to office hours, rewatch the video, pause when you need to, and we will work on this again some more later.